Solar flares emit sudden, strong bursts of electromagnetic radiation from the Sun's surface and its atmosphere, and eject plasma and energetic particles into interplanetary space. Since large solar flares can cause severe space weather disturbances affecting Earth, to mitigate their impact their occurrence needs to be predicted. However, as the onset mechanism of solar flares is unclear, most flare prediction methods so far have relied on empirical methods. The research team led by Professor Kanya Kusano, director of the Institute for Space-Earth Environmental Research, Nagoya University, recently succeeded in developing the first physics-based model that can accurately predict imminent large solar flares. The work was published in the journal Science on July 31, 2020. The new method of flare prediction, called the Kappa scheme, is based on the theory of double arc instability, that is a magnetohydrodynamic (MHD) instability triggered by magnetic reconnection. The researchers assumed that a small-scale reconnection of magnetic field lines can form a double arc M-shape magnetic field and trigger the onset of a solar flare. The Kappa scheme can predict how a small magnetic reconnection triggers a large flare and how a large solar flare can occur. The predictive model was tested on about 200 active regions during solar cycle 24 from 2008 to 2019 using data obtained by NASA's Solar Dynamics Observatory (SDO) satellite. It was demonstrated that with few exceptions, the Kappa scheme predicts most imminent solar flares, as well as the precise location they will emerge from. The researchers also discovered that a new parameter, the magnetic twist flux density, close to a magnetic polarity inversion line on the solar surface, determines when and where solar flares probably occur and how large they are likely to be. Previous flare prediction methods have relied on empirical relations in which the predictions of the previous day tend to continue into the next day even if flare activity changes. In contrast, the Kappa scheme predicts large solar flares through a physics-based approach regardless of previous flare activity. While it takes a lot more work to implement the scheme in real-time operational forecasting, this study shows that the physics-based approach may open a new direction for flare prediction research. Story source: materials provided by Nagoya University. Note: content may be edited for style and length. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you new tech videos. Thank you.